Hello guys, so we're going to be covering section 3.2, which is going to be the product and quotient rules. Okay. So, first things first is if you remember what we talked about recently, we talked about not recently, but in the last section, 3.1, we talked about the power rule. And we talked about how to do derivatives, exponents, and just we learned a few basics for derivatives. But we still have many other cases we need to cover. So the first thing that we're going to be covering is the product rule. So what happens if we take product of two functions? What would the derivatives be then? So let's just say we had f of x and g of x. They're differentiable. You want to find a rule for them. I'm just going to use diff for short. So if you have the derivative of their product, we might say it's just the product of the derivatives. Let's just put a question mark there because we haven't confirmed it yet. But let's just say, maybe perhaps is equal to d of dx, of f of x times d of dx of g of x. Oops, that's a 3. So, it's possible that, maybe this is true. And one of the things is about math, if you're if something is not really true, if something is not true in general, then you can just find a random case and see if it works. Because all you need to disprove something is just one case. So it's always good to start off easy. So let's just say we had a function f of x is equal to x, and we had g of x is equal to x squared. Those are pretty two simple functions. And when we multiply them together, f of x times g of x, we get x cubed. So the derivative here, d of dx of x cubed, and we use a prime notation, that's just equal to 3x squared. But if we do f prime of x, that's just equal to 1. G prime of x is equal to 2x. So we get that f prime of x times g prime of x, I'm going to say is equal to 2x. But that is not equal to 3x squared, which is equal to, f times g prime. So this tells us that this formula does not work. So cross that out. That's not true. So that kind of tells us we have to do a bit more work. We need to be able to figure out what this formula is. So we can use a geometrical argument. So maybe let's use geometry. We could consider a rectangle with sides uv. But, let me kind of clarify what the sides are first. But let's just say we have u is equal to f of x. So u is a function of f of x. And v is also a function as well. Say, u is equal to f of x, v is equal to g of x. And they are positive and differentiable. Differentiable because that's the only way it's meaningful. And the fact that it's positive shouldn't scare you so much, because if a function is positive and differentiable, then its negative is differentiable as well. So if it was negative, we could just make it positive by just multiplying by -1, and that does not change anything. So if we look at their product then as a rectangle, so let's just say we had a rectangle, where this is u. Actually, let me keep it consistent with my notes. I tend to make mistakes if I don't. So let's say this is u and this is v. So this rectangle will have area u times v. So the area equal to u times v. And then, one of the things is about derivatives is that one of the ways we find derivatives is by, adding some changes in x. And I want you to remember this notation right here that we have, delta x refers to like a small change in x. So remember, small change. Thus we get, I'm not going to define it for delta u, but for delta v, that would equate to g of x plus delta x minus g of x. So what we can do now is, if we add that, little change in x now, if we add a little change in x to like v, and we try to add a little change in x to u, then how does this correspond to on this rectangle? And here, let me define delta u as well. So delta u is going to be f of x plus delta x minus f of x. So I'm going to use some different colors now. I'm going to go with yellow. So if we add a delta v, if we add like a little change in x, that means that, we're going to have a little change in area. So that means we're going to increase, the length of this rectangle by delta v. Because a delta x will correspond to a change in, we'll also add, that change in delta v and also add a change in u, so that delta u. So then we have this now extra area of length, delta v times u. Actually, I'll write in the areas afterwards. And likewise for u, we're going to have this like increase in the height, so delta u. And then again, we have this little rectangle right here. And now we're going to have like, a new rectangle now, where it has like a changed area. We increase, we added a bit of change in x, that increased the length of the side. So this new area, what it's going to be is delta u times v. This is going to be delta u times delta v, and this will be delta v times u. So the area of new, I'm going to just say new as in the bigger rectangle, that's going to be, the length of one side times the length of the other. So it's going to be v plus delta v times u plus delta u. Because, this is one side, this is the other side, multiply them together. But you might be asking me now, how does this correspond to, what we're doing above? So you remember what we did above was that we had, like if you, just in case as like you haven't remembered, like you don't remember, but some of the notation that we use for like, dy dx is that we can write it like this. Is that we can define dy dx to be the limit of this, where you have like y as a function of x. So that way we would get, in our like, and remember in the typical definitions of derivative, we have that h term, that is as h goes to 0, but here our delta x is equal to h. So when it corresponds, how does this correspond to the product rule? Is that now we're looking for delta u times v. And remember this was the area, so this is going to be our change in the area is what we're looking for. So our delta uv, the change in our area, or vu or whatever. So what that's going to be is the old one minus the new, or no, vice versa. The new rectangle divided, minus our old rectangle. So it'll be v plus delta v times u plus delta u minus u times v. And we can multiply this out to get u times v plus u delta v plus, I think it was u delta v, v delta u, then plus delta v times delta u minus uv. You might immediately see that here we have u dot v, uv. Well, I said u dot v, but it's just u times v. So u times v minus u times v is 0. So those cancel. So we just get u delta v plus v delta u plus delta v times delta u. And remember what this was equal to? Delta u times v. So it's equal to that change in area. So basically what that's saying is that the area changed by, you know, whatever areas of these rectangles are. All right. Now, if you remember what we had above is that we had, you know, to find that derivative, we need to have that, you know, dividing by that delta x term. We need to divide by that delta x. So now that's what we're going to do here. I'm going to use purple. I like purple. So I'm going to divide by delta x. So I'm going to take everything, divide by delta x. And what that's going to give us is delta u times v divided by delta x. And again, that's the thing that we want to take the limit of. And now I'm going to distribute this delta x to each of these terms. But I'm going to try to put the delta v's and the delta x's together. Or like the, you know, delta over delta basically kind of thing. So the first one's going to be u times delta v divided by delta x plus v times delta u divided by delta x. And this is what I mean by putting them together. Then plus the last one, delta v divided by delta x times delta u. It doesn't matter which one you do. It could be delta v or it could be delta u. Just put it on one of them. All right. So now this is where we're going to take our limit. So if you remember before that when we had the change in the, you know, as we let delta x goes to 0 of like a ratio like this, what we ended up getting was the derivative. So in this case right here, this is going to be like, you know, dv dx. This will be du dx. And this will be dv dx as well. But the question is, you know, what is delta u going to be? Well, remember that, you know, as we have delta x goes to 0, that delta u means, you know, f of x plus delta x minus f of x. And then f is continuous because it's differentiable. Thus, we just get f of x minus f of x, as because we can just plug in 0 basically. We just get 0. So this goes to 0. So let me be clear about how this happens. We're going to let the limit as x goes to 0, well, delta x goes to 0 of, you know, delta u times v over delta x. And I forgot to write this above. I was supposed to write it before. I don't think I can. Actually, I can. Move it over a bit. So remember, this is equal to derivative of u times v of, like, you know, like the derivative of u times v. So now, you know, basically I'm basically going to be doing what I said right here. It's equal to the limit as, you know, delta x goes to 0. And now we're just going to plug in everything above. U times delta v divided by delta x plus v times delta u divided by delta x plus delta v divided by delta x times delta u. And now I'm going to use the limit laws, you know, apply the limits to break up the limits into all the individual pieces that we want. And one of the things we should know, this u has no delta x. Same thing with that v. So we can just pull them out of the limits. We are allowed to just pop them out. So when we use a limit loss to break up, you know, the limit over the sum, we can pull them out while we do that. So that what I'm saying is that what we'll get is u times the limit as delta x goes to 0 of delta v divided by delta x plus v times the limit as delta x goes to 0 of delta u divided by delta x, then plus the limit as delta x goes to 0 of delta u times limit as delta x goes to 0 of delta v divided by delta x. All right. So now what we're going to do is, plug in the definitions. So it'll be u times dv dx plus v times du dx plus 0 times dv dx. But again, this is just 0, so it's just equal to u times dv dx plus v times du dx. So remember that this is equal to d of dx of u times v. All right. So now we just found that rule. So let me put it in terms of functions again, because we like to talk about functions specifically when we talk about derivatives. So again, when we first talk about rules, we need some general cases to work with. So we'll let, if f and g are differentiable functions, then what we have is d of dx, so the derivatives of f of x times g of x is equal to f of x times the derivative of g of x plus the derivative of f of x times g of x. So what this means is that what we do is we keep one the same, take a derivative of the other, then add. Then what we do is once we do that, we add the derivative of the first times the second, not the derivative of the second. So let me just rewrite that in terms of some other notation. You could use f times g prime is equal to f prime g plus g prime f. So it doesn't really matter how you write that. These are commutative. You can swap the order of the addition. Multiplication is also commutative. So you could, write g f prime. Well, you could write g prime, g times f prime plus, g prime f, or however you want to write it. But all you're really saying is, when you take a derivative of a product, is you take fg, you take a derivative of one, multiply by the other, and then take the derivative of the other, multiply by the first one. But, let's do some actual examples. Let's make this concrete, because, otherwise it's not very concrete for you guys. But it's nice to work with examples. So let's just say you want to differentiate g of x is equal to the square root of x times e to the x, and f of t is equal to e to the t times t plus t root t. And this is one of those cases where if you write plus for your t, or t, write your t like that, then you probably need to not do that anymore. But anyways, so you want to find g prime of x, so this is going to be equal to d of dx of the square root of x times e to the x. So remember, like what I said, you keep one of them the same. So I'm going to keep the square root of x the same, multiply by the derivative of e to the x. So I'm going to write prime for that, plus, now it's going to be the derivative of the other one, so square root of x prime times e to the x, because that's the other one. So now let's actually take the derivatives. So the derivative of e to the x is just e to the x, so we just get square root of x times e to the x, plus, and then the derivative of square root of x. Remember that this is equal to x to the 1/2, so we bring down that 1/2, and then subtract 1 to get negative 1/2, so you get x to the negative 1/2 times e to the x. And I'm just going to pull out that e to the x, and then what we get is the square root of x plus 1/2 the square root of x, like that, because that negative just moves it to the bottom. And then for the other example, for the other function that we want to differentiate, it was f of t is equal to e to the t times t plus t root t. And one of the things you should note, t times t root t equal to t to the 1 times t to the 1/2, which is just equal to t times 3 over 2. So when we take a derivative of this is how we're going to do it. All right, so let's keep going now. So f, whoops, that's not what I want. What is? Okay, so f prime of t is going to be equal to, so remember what I said? It's going to be the derivative of the first. Well, actually, I'll mix it up. Yeah, I'll say the derivative of the first. So e to the t prime times the second. And instead of t root t, I'm going to write t to the 3/2. Then plus, you keep the first one the same now, then times the derivative of the second. So this might confuse you because I just swapped the order that I did last time, but the fact is that you can swap these together because they're being multiplied. Multiplication is commutative, you're allowed to move things around a bit, so you're a bit more flexible with this rule. You just have to know, you take a derivative of one, multiply it by the other, and then you add the same thing but vice versa. So let's actually do the derivatives now. The derivative of e to the t is just e to the t. So we get e to the t times t plus t to the 3 over 2 plus e to the t times the derivative of this. So the derivative of t is just 1. Now the derivative of this is going to be, we could bring down that exponent, so 3 over 2 times t, and then we subtract 1 from the exponent. So 3 over 2 minus 1 is equal to just 1/2. So t to the 1/2. All right. So now what we can do is just simplify, or actually you could stop in this step if you wanted to. I'm just going to keep going just because I like to. I want to pull out e to the t from both of these terms. So you get t plus t to 3 over 2 plus 1 plus 3 over 2 t to the 1/2. And that's our final answer. So remember, you'll do the prime here. So remember this was equal to our let's just say h, and this is equal to our g, like g of t, h of t. This was h prime g, then h g prime. So remember, you keep one the same, times it by the derivative of the other. Keep this one the same now, and then times the derivative of the other. All right. So this is basically the product rule now, but now we have to do is the quotient rule. The quotient rule, is going to be a bit more complicated, but kind of talk about what we're doing is that we're going to do the same thing as we did before. So what I mean by what we did before was, the same way we're going to find the way we found the product rule is the same way we're going to do for the quotient rule. So we can find if I can spell, we can find, d of dx. Let's just say f of x divided by g of x, like what we did before. So in this case, instead of working with d of dx and f of x, g of x, we're going to use those deltas again, and we're going to change our variables. So let u, so we're going to do is let u is equal to f of x. We're going to let v equal to g of x, and what we want to find. And oh yeah, one of the other things that's going to be clear when I go through these. At least when I'll try to work on these a bit more and explain what we're doing. But I'm going to explain to you our goal real quick. What you want, well, not explain, but it's always a good idea to say what you want. What do you want to be true? And it's a good idea to have this in mind because, like, whenever you work on a problem, you need to know what your end goal is. What are you trying to show? So what you want is to find the limit as delta x goes to 0 of delta of u divided by v, so the change in a ratio of u and v divided by delta x, because this will be equal to d of dx of u divided by v. So the first thing is we need to find this, then we need to divide by delta x, and then once we divide by delta x, then we want to take that ratio. So likewise, when we did, that delta u times v, we did, we did a change in areas. We took an old area minus, we took the new area divided by the old area once we added a change in x. So likewise, we're going to add a change in x to the ratio u divided by v. And I'm just going to skip a step, but what this is basically going to mean is that we have a new ratio, u plus delta u, v plus delta v, minus u divided by v. And this happens by adding, we get this by adding a delta x. But, that's not so important. The idea here is just, we want to find this change of ratio whenever we change, x a bit. So the first thing I'm going to do is, put these fractions together. So we get u times delta u times v. Then v plus delta v times v. What I'm doing now is just, multiplying, putting the fractions together, multiplying, both of them by the denominator of the other one. So this would be minus u times v, and it'll be v plus delta v, v plus delta v. So let's go ahead and simplify. You're just going to trust me on this. You can verify this on yourself if you like. But these u, v's will cancel. So what we're just going to get is delta u times v minus u times delta v divided by v times v delta v. All right. So now, once we're at this step, this is basically the simplified version of, u divided by v as much as we want. Now we're going to divide everything by that delta x. So divide by delta x. And you might ask me, how are we going to move that in? So remember, one of the things we could do when we divide by delta x is that, this is the same thing as delta x, 1 divided by delta x like that. Or what we could do is just, 1 times delta x in the numerator. That's the same thing. So that's what we're going to be doing. We're going to be multiplying to each term of the numerator. Okay. So thus, once we do that, what we get is the limit, not the limit, the derivative of u divided by v is equal to the limit as delta x goes to 0. And last time I explicitly stated was this, and then plug it in. This time I'm just going to immediately plug that in. Actually, let me write it just to be clear. So, it's equal to the change in the ratio divided by the change in x. And now I'm moving this delta x to right here, and I'm moving this delta x right there. So I'm going to be distributing it in. So you get v times delta u divided by delta x minus u times delta v divided by delta x divided by v times v plus delta v. And similar reasoning to what I did last time when I moved in the limits into each of the terms is what I'm going to be doing right here. I'm going to be basically just moving the limit in via the limit laws. So we get v times limit as delta x goes to 0 of delta u divided by delta x, then minus u times the limit as delta x goes to 0 of delta v divided by delta x, all over v times the limit as, delta x goes to 0 of v plus delta v. And then if you remember what this was before, that's just going to be du dx. So this will be v times du dx minus u times dv dx all over. And remember last time that we actually, whenever we had, just delta v or like delta u in the last case, that went to 0. So if we add that delta v, then, if we add that v, then it just goes to v plus 0, so it's just v, so it'll just be v squared on the bottom. So this form is going to give us, that equation. That's going to give us our quotient rule. Because remember last time we said that, this form is kind of specific. We like it in terms of functions. So that's what we're going to be doing right now. So let's just say f and g are differentiable functions. Again, diff for short. Then what we have is that d of dx of f of x divided by g of x is going to be equal to, so I'm going to be really careful on how I say this. So it's going to be like, what I like to do is, as a mnemonic, what I'm going to say, like, f of x divided by g of x is equal to, like, low, and I'm going to refer to the bottom as high. And when I say d, that means the derivative. And I'll explain this mnemonic in a second. And this is a way, and remember one of those things I kind of like, I like to repeat a lot, but one of the half the battles of math is knowing how to write them and know how to say it. If you know how to say math, and you know how to, like, write it down correctly, and knowing how to read it properly, then it's really, really helpful, especially in understanding what's going on. So keep in mind, when I say low, I'm going to mean f of x, and when I say high, I'm going to mean g of x. So it's going to be low, so g of x, times d high. So it's going to be low times d high. Then that's going to be, so d of dx. So that's what that d means, times the derivative of f of x. Well, not times, but derivative of f of x minus high, so f of x d, and then we say dx, low, which is going to be g of x, and then we say all over low squared. So all over g of x squared. All right. So this one's a little weird so far. And, it's kind of complicated, but this is one you would have to remember. But, again, let me kind of clarify what, the rules are. This time I'll use the prime notation. It's the same thing as g f prime minus f prime g. Whoops, no, that's not it. G prime f divided by g squared. So in this case, this order does matter which derivatives you take first because you're doing a difference here. And the product rule, it doesn't matter which one you take a derivative first because it's just multiplication. You're just, adding, they're like one side on the top, one's on the bottom. In the product rule, they're just being multiplied together and you're allowed to flip-flop them. In this case, you're really not allowed to do that with this, with f divided by g. So you have to be careful when you do this. So the mnemonic, the way I like to remember it is, let's just say we have, I'm going to say low divided by high prime, where, low and high kind of equal like functions. This is like a mnemonic, it's nothing very technical. I like to say low d high minus high d low, whoops, all over low squared. And that's how you can remember the product rule. That's how I remember it. It's just low d high minus high d low all over low squared. Something ingrained for me whenever I saw calculus before. Again, these are all words, these are all rules. So let's do an example. Let's make it concrete. So you want to differentiate the following functions. So the first one is going to be y is equal to x plus 1 divided by x cubed plus x minus 2. Remember that this will be equal to our, like parentheses low divided by high. Or if you want to stick with the other rules, f x divided by g of x. And this is the way this notation might be weird if you don't like that notation, if you don't like using, arbitrary functions of f of x divided by g of x. Just don't try to think about what this means so much. Just think about it as like, you're saying the top of a function, like whenever you do f divided by g of x, the way you want to think about that is just like, what you're writing is a fraction, and f of x is just the top part, and g of x is just the bottom part. That's all that really means. So, we want to differentiate, so we want to find y prime. So remember, it's going to be low, so x cubed plus x minus 2, d high, so x plus 1 prime, minus high, so x plus 1, d low, so x cubed plus x minus 2 prime, all over low squared, so x cubed plus x minus 2 squared. All right, now let's simplify. Actually, I don't need the y prime though. So, let's actually do the math now. Let's take the derivatives. X cubed plus x minus 2, the derivative of x plus 1, that's just 1. Because you just get, x times, the derivative of x is just 1, the derivative of 1 is just 0, and minus x plus 1 times the derivative of x cubed plus x minus 2. So that'll be 3x squared plus 1. Because, derivative of x is just 1, and then derivative of minus 2 is just 0. And again, still all over x cubed plus x minus 2 squared. And you can just trust me on this. I've already done the calculations. But when you simplify, you get negative 2x cubed minus 3x squared minus 3. And then all over x cubed plus x minus 2 squared. So I'm just going to draw a red line where you can stop. So let's say you're doing the problem, you could stop here. Because I'm not really asking you to simplify. And because I mean, I'm not testing your algebra skills, I'm testing your calculus skills. So, and once you know how to do the derivatives correctly, then you don't really need to, like, once you plug in the derivatives and you plugged in everything fine and you don't want to simplify, then that's fine. I'd only ask you to simplify. Like, there was a calculus 1 test I did where the answer was that, where, like, you know, the answer was like of that form. So you were expecting to simplify to 1/2. A lot of people just wrote the square root of 1/2. Well, square root of 1 divided by 2. And I'm just like, can you just please just go the extra step and just say 1/2? Or don't even bother writing the square root of 1, just say 1. So unless it's like something clearly obvious that you should simplify, then please do it. If it's complicated or it takes a bit of time, then I'd rather you waste your time doing something else. Especially during a test. During a test, I do not care if you get the correct answer. I mean, I do care if you get the correct answer, but I'm not going to care if it's simplified, because I don't want you to waste your time doing it on a test of trying to do algebra, which I already know you should be able to do. And besides, you're easily just to make a mistake. All right, so our second example that we're going to do is f of x is equal to 1 minus x times e to the x divided by x plus e to the x. So this right here, this will be like a chain rule. Well, not like a chain rule, this will be a product rule, my bad. So remember, it's going to be low, so x plus e to the x, d high, so 1 minus x e to the x prime minus high, so x plus, oops, not that one, 1 minus x e to the x, you know, then d low, so x plus e to the x prime all over low squared. All right, so I'm going to do some math off on the side and kind of say what this is. So 1 minus x e to the x, what this is going to be equal to is, you know, we're going to basically take the derivative of that. The derivative of 1 is just 0. Then we have the minus, and then we have to use the product rule on x. So we keep 1 the same, so x times the derivative of e to the x, so e to the x, plus the derivative of the other one now, so derivative of x, just 1, times e to the x, and then what we get in the end is just negative x times e to the x minus e to the x. Or if you want to pull out the negative, that's the same thing as x e to the x plus e to the x. And you're welcome to verify that if you want. Just remember to do it slow, and if it takes a bit of time, don't worry about it. Remember, when you first learn these rules, the trick is to just go slow and make sure you get the details right. All right, now let's go back to doing the problem. So we have x plus e to the x. And then what I just said, so this derivative was, this is equal to that. I'm going to pull out the negative, put it in front, and then we just get x times e to the x plus e to the x minus 1 minus x e to the x. Then times the derivative of x plus e to the x. Derivative of x is just 1. Then plus the derivative of e to the x, which is just e to the x. And then still all over x plus e to the x squared. All right, and this is where we can stop. So, and this is our final answer. So this is fine. So we can stop here. We don't need to simplify anymore. Like I said, this is fine. I'd rather you spend your time on a test doing calculus instead of algebra. But, you know, that's it for the section. It's not too hard or anything. I would recommend just, like, you know, taking it slow, kind of maybe finding a way for yourself to memorize the product rule and the quotient rule, because they can be a bit tedious at first. And I wouldn't want you to do them, I wouldn't want you to, spend a lot of time trying to remember things. Especially, the test is open note, but I would highly recommend trying to memorize these things. You don't need to know the proofs, not really. The proofs are nice, but they're only there to give you a bit of intuition of what's going on and how we find these things. But the more important thing is just knowing what they are. So if you can do that, then you're doing well. But I think that's it for this section. Thank you for watching. Like, comment, and subscribe. Sorry the video came up a little bit late. Again, my notes were just my notes were being weird, and I didn't really like them. And I had to go over them a few times. But again, thank you for watching. Adios.